Okay, so this is page 13, and this is part of a Do Now for class, which I'm going to go over. So hopefully you have finished both pages 13 and 14. And when you're done, or if you have questions, you can watch this video. So number 16 says, which equations represent proportional relationships? And if they are proportional, what is the constant of variation or the constant of proportionality? If it is a direct variation equation, then x and y are proportional. After you determine its direct variation, demonstrate this in a chart and on a graph. Okay, so for the first one, to figure out if it is a proportional relationship, I want to see if I can put it in the form of y equals mx plus b, where b equals 0. So I'm going to divide by 4, and I get y equals x. So the constant of proportionality would be 1, because here I'm multiplying by 1. B equals 0, which means it is a proportional relationship. Okay, now for this one, 2y equals negative 3x plus 6. Divide by 2, divide by 2, divide by 2. Y equals negative 3/2 x plus 3. B does not equal 0, therefore it is not a proportional relationship. So there is no it is not a proportional relationship, so there's no constant of variation. Now it wants me to make a table of this and graph the results. So for this first one, if y equals x, then if x is negative 2, y is negative 2, 0, and 2. And y over x would be 1, which is what I already knew. So now I'm going to graph this. I'm going to graph negative 2, negative 2, 0, 0, 2, 2. And it's a straight line through the origin, which is what I expect when I know it's a proportional relationship. Now I'm going to graph this one, and I'm going to hope that it doesn't go through the origin, because if it's not proportional, I don't expect that it would go through the origin. So if x is 0, y is 3. If x is negative 2, this is 6. If x is negative 4, that's 9. And if x is negative 6, that's 12. So here, if I do 3 over 0, it's undefined. If I do 6 over negative 2, it's negative 3. This is negative 9/4, and this is negative 2. So as I suspected, there is not a constant when you put y over x. And when I graph this, I'm going to go down 3 over 2. It's going to look like this. It's a straight line, but it does not go through the origin. So once again, showing that if you have a proportional relationship between x and y, then when you put y over x, it's constant, as it was in the first one. And when you put it in slope-intercept form, the b is 0, like it was in the first one. And it did not occur that in the second one. Okay, so now we do the same thing with these two. Okay, so for this one, I divide by 3, divide by 3, divide by 3. Y equals 4x minus 2. This is not a proportional relationship. B does not equal 0. If I go to graph it, it's going to look like this. It's not going to go through the origin. If I plug in values, this is negative 10, negative 2, 6. This negative 10 over negative 2 is 5. Undefined 3. No constant when I put y over x. It does not go through the origin, and b was not equal to 0. So on all counts, this is not a proportional relationship. Let's look at this one. This is y equals 4/3 x. B equals 0, so the constant of proportionality is 4/3. When I plug in values here, this becomes negative 4. This becomes negative, wait a minute, let me make sure I did that right. When I plug in a negative 3, yeah, that's negative 4. when I plug in -2, that's -8/3. When I plug in 0, that's 0. When I plug in 2, it's +8/3. Now, when I put -4 over -3, I get 4/3. When I put -8/3 over -2, when dividing, don't ask why, I flip the second and multiply. So this is the same as multiplying by -1/2. That gives me +8/6, which simplifies to 4/3. So 4/3, 4/3. And when I put, this is the same thing. I'm going to put +2 over +8/3 over +2, and I also get 4/3. So I get the same constant of proportionality every time I pick numbers and then I put y over x. And when I graph it, it does go through the origin. Okay. Now, if I go to the next page, this says determine whether each of the tables represents a proportional relationship. Okay, so do these and stop the video and start it again to see if you are correct. So I see a table. If I want to know if it's a proportional relationship, I compare all of the y's over x. 6 over 1 is 6. 12 over 2 is 6. 18 over 3 is 6. 24 over 4 is 6. And 36 over 6 is 6. So my constant of proportionality here is 6, so my equation is y equals 6x. And the answer is yes, it's a proportional relationship. Now for this one, when I put y over x, I get 14 over -4 becomes -7/2. This is -7/2. This is -7/2. This is -7/2. And this is -7/2. So again, the answer is yes, and the equation is y equals -7/2x. For the next one, 6 over 8 is 3/4, right? But -12 over -4 is 3. So the answer to this is no. Number 3 is a big no. Okay, for D, I get -2 over -32 is 1/16. 5 over 80 is 1/16. This is 1/16. This is 1/16. And this is 15 over 240. And how many times does 15 go into 240? I suspect it's going to be 16. And it is. So this is a yes, and it's y equals 1/16 x. Okay, now here this says, are these equations, do these represent a proportional relationship? And if it is, specify the constant of proportionality. So this is yes, because b is 0. And the constant of proportionality I'll call a equals 6. This is no, b does not equal 0. This is yes, a equals 1/2. Divide by 3, and then y equals 2x, that's a yes. B equals 0, a equals 2. This is divide by 5, y equals 1/5 x. Notice that x over 5 is the same as 1x over 5, which you can see is the same as 1/5 x. So this is a yes, a is 1/5, and b equals 0. This is 5y equals 15x. Divide by 5, y equals 3x. B equals 0. This is a yes, and the constant of proportionality is 3. then for the last one, I divide by 3, divide by 3, divide by 3. Y equals 3x minus 2, and the answer is no, because b does not equal 0. Okay, that's the end of this video.